there. This is the pre-algebra class for the week I'm missing. That's October 2nd. You can start this beforehand if you like. So today is the 27th. That's Tuesday. I'll be gone on Monday. The basic plan is for you to have looked at this video before class and to work on these problems during class so you guys can kind of help each other. So I'm going to go over what it is you're looking at. We are moving on to actual kind of algebra-y stuff and chapter 2 today in your book, and the homework is going to be on page 69 and 74. That's sections 2.1 and 2.2. The first section is using words that nobody ever uses except in Mathland. And so that's these three words: the associative property, the commutative property, and the identity property. And you ask yourself, why do people ever want to use this? And the answer is nobody ever wants to use these stupid things. But they just know them. Eventually, you just do them because you know them. Nobody remembers the words unless you're a math teacher. So I'm not real big at you memorizing the words. I'm more big on you understanding the concepts. So it's really, really simple for you. You probably do this intuitively. You just need to give a word to it. So when you get some math problems and they say, okay, use this to do that, it makes sense. For section 2.1, that's what they're talking about. For section 2.2, they talk about what's called the distributive property. Now, the distributive property is probably the most commonly used concept in all of algebra. And so understanding it backwards and forward, sideways, is really, really important, or you cannot continue to do lots of algebra stuff. So here's what it means, basically. The associative property comes from the term, and we use it all the time, to associate. That means to group up. So if you are going to group up with somebody, you are to associate with somebody. So for example, our class is a group. Our school is a group. And if we were to take, for example, our pre-algebra class is one group, and you add our algebra class together, they would be another group. So it's really grouping. Now in math, how this works is that we say that there are certain rules that work with associating together. And it's primarily dealing with multiplication. And we covered this a little bit in the rules on PEMDAS, but I'm going to be more specific on it. So, for example, again, we're looking at the associative property. So I generally will call that ASSOC rather than write out the whole word. So associative property. So for example, if I were to say um, what's the rule here? Well, let's see if I can think of a good example. Okay. 6 plus 81 plus 9. Simple problem. You would do 6 plus 81 is going to be 87. 87 plus 9 is 93. So that's where we start. We have 6 plus 81 plus 9 is 93. That's a fine and wonderful way to do things. However, sometimes it's useful, and this is what we call mental math more than anything else, to associate things together or group things together. And what I'm going to do is, if I group 81 plus 9, that's a fairly easy math problem. What's 81 plus 9? Well, that's 90. 90 plus 6, so that's 90. 90 plus 6 is just 96. And I did that kind of in my head. How come I get a different answer? Well, the answer is because 6 plus 81 is 87. 87 plus 9 is 96. It's easier to make a mistake when you just kind of go and you just kind of keep it rolling in your head and you say this plus this plus this plus this plus this. So most people, when they do mental math, they don't just go and just add them together because it's really easy to make mistakes. They group them together. Well, grouping them together is just using what we call the associative property. In other words, it doesn't change the answer. It just helps you figure out the answer. And by associating. It really doesn't matter how you group them. In some problems, they'll say, here, group it this way, or they'll say, hey, group it that way. Um, and your life is good. So a little simpler version of that would be, say, this problem. Um, 2 plus 7 plus 3. And you ask yourself, how might I associate that? Well, I know 7 and 3 is 10, right? So that's the same as 12, because 2 plus 10 is 12. And that's how actually I do this in my head. I associate. And but also I could have associated this 2 plus 7 plus 3, right? Doesn't change it. So 2 plus 7 is 9, 9 plus 3 is 12. That's an easy enough problem that I can do it in my head. And that's really all we're doing when we say using the associative property is I'm grouping stuff together. You don't really see it much in math, but you're going to have times where it's going to be helpful for you mentally to group things. And sometimes actually on paper, you want to group things together. In an algebra, guess what? It's all the time. You're grouping stuff together and you just do it. Okay, let's move on to the commutative property. What's the commutative property? Well, again, I will generally just call that COM or COMM. Commutative property is a little bit obvious for most people, but it means that you can reverse things. So for example, 3 plus 4, that's the same as 4 plus 3. When you add, you can reverse them and it does not change the answer. That's a property of math, or it's a kind of a rule of math that we just learn because it's obvious. We give it a name because um, you got to give everything a name when there's a rule on why you can do stuff. Also works for multiplication. So if I were to say 5 times 3, that's the same as 3 times 5, right? 5 times 3 is 15, 3 times 5 is 15. That works really well. In algebra, you see more like this, where you see 7 times x times y. Well, that's the same as x times 7 times y, which is the same as y times x times 7. It does not matter the order when you multiply stuff, and it does not matter the order when you add stuff. You can make them so that it is simple. In general rule is this one's better than that one or that one. And you ask, why is this one better? Well, general rule is we put numbers first, then we put letters second. And then if we have more letters, then we put the next letter. Well, how do we know which letter to put first and second and third? The answer is we go in alphabetical order. X is before Y in the alphabet, so we generally say XY. It's the same as saying 7YX, but we generally go with this one because X is before Y. That's why we do it that way. And so sometimes it's important that you go ahead and you know that you're going to be able to multiply them around in any order, and that's called the commutative property. Same thing with the addition, commutative property of multiplication, the commutative property of addition. This is multiplication, this is multiplication, this is addition. It just means you can switch around the order, but they're all called the commutative property. Then there's the last one, which is called the identity property. And it's, I don't know, it's stupid. Identity means if you take something times 1, it equals itself. So if I have 3 times 1, guess what it's going to equal? 3. It's identity. That means it is itself. That's it. That's the identity property. Anything times 1 is itself. Now, where you might find that helpful is if you say, okay, I want to find 3/4. This is a 3/4. And whoa, yes, try that again. So if I just say 3/4, that's a normal fraction. If I multiply something times 1, does it change it? The answer is no. Well, if I wanted to say instead of fourths, I wanted, let's say, 20ths. If I multiplied 4 times 5, 4 times 5 is 20. 3 times 5 is 15. 3/4 is just 15/20. How do I know that? Because I just took 3/4 and I multiplied it times 1. 5/5 is, think of a pie, 5/5 of a pie is 1. And so we use the concept of times 1 to get an answer, not usually just for this reason, because that's stupid, but in the context of fractions, we use it all the time, where we take something, multiply it times 1 to give me something that is more useful to look at. If I have 20 people in the room and I want to put 3/4 of them in white outfits and 1/4 of them in brown outfits, how many do I do? Well, I can just do this little fraction. That means 15 go into white outfits. And so that's the identity property. We don't use it much by name. We just know that it is, that when you multiply something times 1, it's itself. Okay, so that is pretty much section 2.1. And you have some properties or some questions that ask, like, okay, here's 12RS, and that's equal to 12R times S. Which property are we talking about? The associative, the commutative, or the identity? Well, in this case, we aren't changing the order. We're just changing how you're grouping them. I'm grouping the RS. Over here, I'm grouping the 12 and the R. So it's the associating. So whenever you're grouping something, changing, that's the associative property. Then you have another question that might be something like, okay, what's this property? 8 plus 0 is 8. Well, this is the identity property. In multiplication, you would say 8 times 1 is 8. This is the identity property in addition. In other words, if you add 0 to something, it doesn't change it. In multiplication, if you times it by 1, it doesn't change it. That's the identity property. And you also have a question that says, okay, how about what's this property? 8 times 3 times 2 equals 8 times, let's see what I meant, 8 times 3, sorry about that, 8 times 3 times 2. In this case, what am I doing? Again, I'm associating because I haven't changed the order. I haven't done anything funky with it. I'm just writing it in a different grouping of it. In mental math, if I were to try and find the answer to the question, in some questions, I might want to group them because I know them. So let's do a mental math thing here. 3 times, and I'm going to use the dot, which I rarely use, 3 times 15 times 10. Okay, how would I group that? In this case, in my head, I know 15 times 10 is 150. Well, what's 3 times 150? That's 3 times 150, that's 450 is the answer. That's if I grouped it this way. If I said, okay, what about if I group it this way? What's 3 times 15? 3 times 15 is 45. 45 times 10 is 450. Which one's easier to go 3 times 15 or 3 times 150? I probably would have grouped it this way. And it becomes 45 times 10. So again, it's just a way to mentally group things to make it a little easier. Sometimes grouping it one way is easier than another. Okay, now section 2.2 in your book, the distributive property. This one is used all the time. It's primarily used in multiplication, not addition. You distributing times multiplication. What it means is that you can, I'll just give you an example. 3 times 4 plus 1. Okay. If you remember PEMDAS and I were to try and answer that question, 4 plus 1 is 5. Do that first. 3 times 5 is 15. Okay. The distributive property is when you have something times some things in parentheses, you can basically say it's the same as this times that plus this times that. So this would be the same as 3 times 4 plus 3 times 1. Well, 3 times 4 is 12 plus 3 is 15. So in this particular example, 3 times 4, I'm distributing 3 times 1, distributing. Distributing means like handing out. So if you think of it as you are at Friday at Pioneer Bible Church and there's a bunch of people there and there's a food distribution. And so here's you distributing a little bit to you and a little bit to you and a little bit to you. And that's why it's called the distributive property. So this guy actually interacts with every character in the group. Another example is do 1 5 times 3 plus x plus 4 plus 9. Well, distributive property says that's the same as 5 times 3 plus 5 times x plus 5 times 4 plus 5 times 9. That's the distributive property. If I could add all those things together, that'd be fine. Sometimes it makes sense to do it that way. Sometimes it makes more sense to distribute them out. But the answer is the same. That's the deal with distributive property. Doesn't matter what is in the parentheses. You just take this thing times each one and write them. Now the symbols between, I've got plus. What happens if that's a little different? Okay, so to help you figure this out, I'm giving you 3 examples of distributive property. One like what we've just done. So this top one, if I were to say what's 3 times 2 plus 6? Well, you could in your head just say, well, 2 plus 6 is 8. 3 times 8 is 24. That works. Using the distributive property, 3 times 2 is 6. Plus 3 times 6 is 18. Well, that's equal to 24. It works. Okay. I used, this was a positive times a positive. That's a positive times a positive is positive. What if you have a negative sign in here? Well, what's 2 minus 4? Well, that's negative 2. What's 5 times negative 2? That's negative 10. So this problem, the answer would be negative 10. Let's use the distributive property. 5 times 2 is 10. 5 times negative 4, or minus 5 times 4, which is 20. Well, what's 10 minus 20? Well, it's negative 10. So this is this deal. Now I'm going to write this even one more time and go back to what we did in the last lesson. This is in your head, and this is why in your head was so important last time. This is a positive 5, a positive 2, plus a negative 4. Okay, so I want you to think of it that way. A positive 5 times a positive 2 is a positive 10, plus a 5 times a negative 4 is a negative 20. See how 10 minus 20 is the same as 10 plus a negative 20? This way is how I actually think about it. So I go positive 10, negative 20. Positive 10, negative 20. Okay, well, what if you got a bunch of other ones? So again, this one, a negative 5 times a negative 3 is a positive 15. A negative 5 times a positive 9 is a negative 45. Well, what's 15 minus 45? Remember, for those of you who remember, it's the big number minus the small number, and that's your answer. And the sign is whatever the big number is. So what's 45 minus 15? That's 30. Which one has the bigger sign? The 45. So it's a negative 30. Answer, negative 30. So that's how you do it. So you distribute when they're positive and negative numbers. In your head, you're saying this is a negative 5, a negative 3, a positive 9, and you're saying that times that times that, and you're just adding them all together. Okay, lastly, what if we throw letters in there? It is the same thing. It is 3 times 6x. Well, that's 3 times 6 times x, right? Plus 3 times 4, which is 12. Now, again, we normally do 3 times 6. That's 18x plus 12. That would be the answer. And it's that simple. You can't really add 6x plus 4 because they're different things. This is 6 x's and this is 4 numbers. You can't add numbers and letters together. You can only add things that are the same. So these are x's. There's 6 of them. and these are 4 numbers. Numbers are not x's. So we have to use the distributive property to simplify this into something simpler. It also works in reverse. If I were to say 6x plus 4 and put the 3 on that side, does it matter if the 3 is on the right side or if it's on the left side? Again, you may not remember the term, but the commutative property says it doesn't matter the order. 5 times 3 is the same as 3 times 5. So in this case, in my head, I would say 3 times 6x. Well, 3 times 6 is 18. It's 18x. 3 times 4 is 12. Same answer. It doesn't matter whether it's first or second. So you will have some problems where they will put the number in front and some where they will put it behind. And that's how you do those. Okay, let me give you one that's got a little bit more negative numbers in it. So let's say like you have negative 7 times 5 minus b. B being an algebra number. Okay, how do we do this one? Negative 7 times 5. Well, what's 7 times 5? It's 35. So it's negative 35. Negative 7 times a negative b. What's a negative times a negative? Remember, a negative times a negative is a positive. So 7 times b is 7b. That's the answer. So this one is the same as what we were doing before. It just has got more negative signs, and that tends to mess people up. That's why you have a bunch of practice problems to try them and to make sure that you're tracking them. And eventually this will sink into your head what you're supposed to do. Well, good luck with the homework. The homework will be fun, and I will see you when I get back.